Have you ever looked at a mushroom and wondered if you were staring at the future of human civilization? Well, unless you spend a bit too much time on a Thailand beach, chances are that you haven't. But right now, at this very moment, scientists and engineers are discovering that one of Earth's oldest organisms might hold the key to solving some of our biggest problems. We're not talking about food or medicine, though mushrooms do both brilliantly. We're talking about something far more radical. Buildings that grow themselves, packaging that dissolves harmlessly into soil, materials stronger than concrete that are completely biodegradable, leather without animals, insulation that cleans the air, even computers made from living fungal networks. This isn't science fiction. This is happening right now, and what you're about to discover will completely transform how you see the humble mushroom. Hey everybody, and thanks for tuning into our channel. The future is now, and we are here to explore and reveal all the latest and greatest technological breakthroughs from around the world. Be sure to subscribe to make sure you don't miss out on our daily uploads. Now let us dive in. Let me start with something that sounds absolutely impossible. Imagine walking into a building where the walls literally grew themselves. Not assembled, not constructed in the traditional sense, but grown from living organisms in a matter of weeks. In 2014, a company called The Living built a 40-foot tall tower in New York City's MoMA PS1, and the building blocks weren't bricks or steel. They were mushrooms, or more precisely, mycelium, the root structure of fungi. Here's how it works, and trust me, once you understand this process, you'll never look at construction the same way again. Mycelium is essentially nature's underground internet, a vast network of thread-like structures called hyphae that spread through soil, connecting plants, decomposing organic matter, and forming the foundation of forest ecosystems. These structures have an almost magical property. They grow rapidly, binding together whatever substrate they're growing through, and then when you dry them out, they stop growing but retain their structure, creating a solid, lightweight, incredibly strong material. The team at The Living took agricultural waste, corn stalks, and other plant matter that would normally be thrown away or burned, mixed it with mushroom spores, and packed it into brick-shaped molds. Then they simply waited. Over the course of just a few days, the mycelium grew through the agricultural waste, binding it together into solid bricks. Once the bricks reached the desired density and strength, they were dried, which killed the mycelium and stopped any further growth. The result was 10,000 biodegradable bricks that were strong enough to build a 3-story tower. Think about what this means. The energy required to produce these bricks was minimal. No firing in kilns at thousands of degrees like traditional ceramics. No chemical processing like plastic. No mining and smelting like metal. Just mushrooms eating agricultural waste and transforming it into building material. And when the exhibition ended and the tower was no longer needed, those 10,000 bricks didn't go to a landfill. They were composted. They simply returned to the earth, feeding the soil just like any other organic matter. The tower was called Hi-Fi, and it proved a concept that seemed too good to be true. We can grow buildings. But that was back in 2014, and the technology has advanced dramatically since then. Companies all over the world are now exploring mycelium-based construction materials, and what they're discovering is extraordinary. Ecovative Design, a company founded by Eben Bayer and Gavin McIntyre when they were still undergraduate students, has been at the forefront of this revolution. They've developed a mycelium-based material they call mycocomposite, and it's being used for everything from packaging to furniture to actual building components. Their flagship product for years was mushroom packaging, a replacement for styrofoam that protects products just as well but decomposes completely in a matter of weeks if you throw it in your garden. Major companies have taken notice. Dell used mycelium packaging for their servers. IKEA has explored it for protecting furniture during shipping. Crate & Barrel experimented with it for their catalog products. These aren't small startups making fringe products. These are massive global corporations choosing mushroom-based materials over petroleum-based plastics. But the applications go far beyond packaging. Ecovative has developed mycelium-based leather called forager hides, and it's virtually indistinguishable from animal leather in appearance and texture. Fashion companies including Hermès, Stella McCartney, and Adidas have all created products using mycelium leather. Hermes made a version of their iconic Victoria bag with mushroom leather. Adidas created a shoe called the Stan Smith Milo, where the upper is made entirely from mycelium. The implications for the fashion industry are staggering. Leather production is incredibly resource-intensive and environmentally damaging. It requires vast amounts of land for grazing animals, produces significant greenhouse gas emissions, and the tanning process uses toxic chemicals that pollute waterways. Mycelium leather can be grown in controlled environments in just a few weeks, requires minimal water and energy, produces no toxic waste, and when you're done with the product, it biodegrades completely. And here's something that's even more remarkable. You can tune the properties of mycelium materials by changing what you feed the fungus and how you grow it. Want something flexible like leather? Grow it one way. Want something rigid like wood? Grow it differently. Want something with specific insulation properties? Adjust the growth conditions. It's like having a programmable material that you can customize for specific applications. MycoWorks, another pioneer in this space, has developed a material called fine mycelium that has caught the attention of luxury fashion houses. Unlike other mycelium materials that grow through agricultural waste, fine mycelium is grown in thin sheets, more like how leather naturally forms on an animal. The result is a material with a grain structure that closely mimics traditional leather. General Motors has partnered with MycoWorks to explore using fine mycelium for automotive interiors. Imagine sitting in a luxury car where the seats and dashboard are covered in mushroom leather. But let's move beyond fashion and packaging and talk about something even more fundamental: the buildings we live and work in. The construction industry is one of the largest contributors to global carbon emissions. Concrete production alone accounts for approximately 8% of global CO2 emissions. Steel production adds another significant chunk. The materials we use to build our world are literally cooking the planet. Mycelium offers an alternative that seems almost too good to be true. Researchers at institutions like MIT, Stanford, and various universities across Europe are developing mycelium-based building materials that could partially or entirely replace concrete, insulation, and even structural components in buildings. NASA has funded research into using mycelium to grow habitats on Mars, where shipping building materials from Earth would be impossibly expensive. The idea is that astronauts could bring fungal spores and growth medium, then grow their habitats using local Martian soil as the substrate. Phil Ross, a mycelium artist and researcher, has been growing furniture and even small structures from pure mycelium for years. His work demonstrates that you can create intricate shapes and forms by controlling how the mycelium grows. He's made chairs, lamps, and architectural elements that are entirely fungal. The strength of these materials is surprising. Mycelium composites can have compressive strength comparable to conventional insulation materials, and even some types of concrete, while being a fraction of the weight. But construction materials are just scratching the surface. Let's talk about something that sounds like pure science fiction: mycelium electronics and computing. Researchers at the Unconventional Computing Laboratory at the University of the West of England have been exploring something called mycological computing, or using living fungal networks as information processors. Remember, mycelium is essentially nature's internet, a vast network that communicates through electrical and chemical signals. When one part of a mycelial network detects something like food or a threat, that information spreads through the entire network. Scientists have discovered that you can actually interface with this network. By placing electrodes on mycelium and measuring the electrical impulses that travel through it, you can detect distinct patterns of activity. Some researchers are exploring whether these patterns could be used as the basis for biological computers or sensors. Imagine a building wrapped in living mycelium that acts as a sensor network, detecting air quality, moisture levels, structural stress, or even the presence of specific chemicals. Andrew Adamatsky, a computer scientist and director of the Unconventional Computing Laboratory, has published research showing that mycelium networks can process information and even exhibit learning-like behaviors. When you stimulate one part of a fungal network, other parts respond, and the network's response changes based on previous stimulation. It's a form of biological memory. Now, we're not about to replace silicon chips with mushrooms anytime soon, but the research opens up fascinating possibilities for biological sensors, environmental monitoring systems, and hybrid bioelectronic devices. Imagine a pollution monitoring network grown from fungus, spreading through soil and water, continuously sensing contamination, and transmitting that information through its natural electrical activity. Let's shift to another extraordinary application: environmental remediation. Mycelium doesn't just consume agricultural waste, it can break down and neutralize many toxic substances that we have no other good way of dealing with. This process is called mycoremediation, and it's being used to clean up everything from oil spills to radioactive contamination. Paul Stamets, perhaps the world's most famous mycologist, has been a tireless advocate for mycoremediation. His research and that of many others has demonstrated that certain fungal species can break down petroleum products, pesticides, herbicides, and even some heavy metals. After the Deepwater Horizon oil spill in the Gulf of Mexico, mycoremediation was explored as a cleanup strategy. Oyster mushrooms and other species were shown to be capable of breaking down the oil into harmless compounds. In the aftermath of the Chernobyl nuclear disaster, scientists discovered that certain fungi were actually thriving in the highly radioactive environment. These fungi weren't just surviving the radiation, they were feeding on it. They contain melanin, the same pigment that colors human skin, and they use it to convert radioactive gamma radiation into chemical energy, similar to how plants use chlorophyll to convert sunlight. These radiotrophic fungi could potentially be used to decontaminate radioactive sites, or even to protect astronauts from cosmic radiation during long space missions. The implications of mycoremediation are enormous. We've created vast quantities of toxic waste that we don't know what to do with. We bury it, seal it in containers, or dilute it and hope it breaks down eventually. But fungi offer a biological solution. We could use mycelium to digest contaminated soil, breaking down toxins into harmless compounds, while simultaneously enriching the soil with organic matter. Areas that are currently unusable wastelands could be transformed back into productive land. Now let's talk about something that affects all of us directly: food and agriculture. We're facing a global challenge of feeding an ever-growing population with finite agricultural land and resources. Traditional meat production is particularly problematic, requiring enormous amounts of land, water, and feed while producing significant greenhouse gas emissions. This is where mycelium offers another revolutionary possibility. Several companies are developing mycelium-based meat alternatives that aren't trying to mimic meat. They're creating an entirely new category of protein. Meaty Foods has developed whole muscle cuts made from mycelium that have the texture and protein content of chicken or steak, but are grown in a matter of days in controlled fermentation tanks. Unlike plant-based meat alternatives that grind and process various ingredients to approximate meat texture, mycelium naturally grows in fibrous structures that resemble muscle tissue. The nutritional profile is impressive. Mycelium is high in protein, contains all essential amino acids, is rich in fiber, and has virtually no saturated fat. It's also incredibly efficient to produce. While raising a cow requires years of feeding and massive land use, mycelium can grow to harvest size in just a few days, using a fraction of the resources. Nature's Find, another company in this space, is producing a mycelium-based protein they call Phi protein, derived from a fungus originally discovered in the thermal acidic springs of Yellowstone National Park. This organism thrives in extreme conditions, which means it can be cultivated in a wide range of environments. They're using it to create everything from meatless breakfast patties to dairy-free cream cheese. Fungi also play an essential role in regenerative agriculture. The mycelial networks in healthy soil form symbiotic relationships with plant roots, dramatically increasing the plant's ability to absorb water and nutrients. These mycorrhizal associations have been shown to increase crop yields, improve plant resistance to drought and disease, and reduce the need for chemical fertilizers. Farmers are increasingly using mycorrhizal inoculants, essentially fungal spores that you add to soil to establish these beneficial networks. Let's talk about plastic pollution. We've created a world drowning in plastic. It's in our oceans, in our soil, in our bodies. Microplastics have been found in the most remote locations on Earth, from the deepest ocean trenches to the peak of Mount Everest to human placentas. We desperately need alternatives, and mycelium might be one of the most promising. We've already discussed mycelium packaging, replacing styrofoam, but the applications go much further. Researchers are developing mycelium-based materials that could replace single-use plastics in countless applications. Disposable plates and cutlery, food containers, protective packaging, consumer product cases, all could be made from mycelium-based materials that perform just as well as plastic but decompose completely in weeks or months rather than centuries. There's also fascinating research into fungi that can actually digest plastic. Certain species have been discovered that produce enzymes capable of breaking down polyethylene and polyurethane, two of the most common and problematic plastics. Pestalozziopsis microspora, a fungus found in the rainforests of Ecuador, can survive on polyurethane as its sole carbon source. Other species have been found that can digest polystyrene. These discoveries open up the possibility of mycoremediation of plastic waste. Vast garbage patches in the ocean, landfills overflowing with plastic waste, contaminated areas where plastic has accumulated, all could potentially be treated with fungal cultures that would slowly digest the plastic and convert it into harmless organic matter. Now, let's explore something that connects many of these threads: the fundamental shift in how we think about materials and manufacturing. For the past century, our approach has been extractive and energy intensive. We dig things out of the ground, heat them to extreme temperatures, combine them with toxic chemicals, shape them into products, use them briefly, then throw them into landfills where they sit essentially forever. It's a linear system: extract, make, use, dispose. Mycelium represents a completely different paradigm. It's circular and regenerative. You start with waste products that would otherwise be burned or buried. You combine them with a living organism that transforms the waste into valuable material using minimal energy. You use the product for as long as needed. When you're done with it, it becomes food for the next generation of organisms, returning nutrients to the soil. It's a closed-loop system that mimics natural ecosystems. This shift from linear to circular systems isn't just environmentally beneficial, though that alone would justify it. It's also economically transformative. In the current system, we're constantly running out of virgin materials and dealing with mounting waste. Prices fluctuate based on resource scarcity. In a circular system based on biological growth, waste becomes feedstock. The more we produce, the more material we have available for the next cycle. We're also seeing the emergence of distributed biomanufacturing, where instead of massive centralized factories, production happens in smaller local facilities. Because mycelium grows so quickly and the inputs are agricultural waste that's available everywhere, you could have mycelium production facilities in every region, using local waste streams to create local materials. This reduces transportation costs and emissions, creates local jobs, and makes communities more resilient and self-sufficient. Imagine a future where every city has biofactories growing materials from local waste. Construction companies source mycelium building materials from a facility that's processing agricultural waste from surrounding farms. Product manufacturers grow their packaging on-site from sawdust or other waste from their production process. Fashion companies grow their leather locally using waste from food processing. Now, let's address something important. Mycelium technology isn't perfect, and there are legitimate challenges that need to be addressed. One issue is water resistance. Mycelium materials, being organic, can absorb moisture. Left untreated in damp conditions, they could potentially start growing again or develop mold. Researchers are developing various treatments and coatings to address this, but it remains a challenge for certain applications. Standardization is another issue. Unlike conventional materials with consistent properties, biological materials can vary based on growing conditions, substrate composition, fungal strain, and other factors. For mycelium materials to be widely adopted in construction and manufacturing, we need reliable standards and quality control processes. Scale is also a consideration. While mycelium grows quickly, scaling up production to meet global demand for materials requires significant investment in facilities and infrastructure. We're talking about replacing industries that have had decades to optimize their processes and build global supply chains. That transition won't happen overnight. But despite these challenges, the momentum is undeniable. Investment in mycelium-based companies has grown exponentially over the past decade. Major corporations are partnering with mycelium startups and integrating these materials into their products. Regulatory frameworks are being developed to govern the production and use of mycelium materials. Perhaps most importantly, public awareness and acceptance is growing. Consumers are increasingly demanding sustainable alternatives to conventional materials, and they're willing to pay premium prices for products that align with their values. This creates market pull that accelerates the adoption of technologies like mycelium-based materials. One of the most exciting aspects of this field is how much we still don't know. We've identified thousands of fungal species, but scientists estimate that we've only discovered a small fraction of the total diversity that exists. Each species has unique properties and capabilities. Some might produce materials with unprecedented strength. Others might digest specific toxic compounds that nothing else can break down. The convergence of mycology with synthetic biology, genetic engineering, and artificial intelligence could lead to breakthroughs we can barely imagine. AI could analyze fungal genomes and predict which genetic modifications would produce desired material properties. As genetic engineering could create fungal strains optimized for specific applications. Automated biofactories could grow materials with computer-controlled precision. We're standing at the beginning of what could be called the Mycelium age, a period where fungal technology becomes as fundamental to our civilization as steel and plastic were to previous generations. The buildings we live in, the clothes we wear, the packaging that protects our products, the insulation in our walls, the materials in our cars, even the food we eat, all could have mycelium as a key component. And perhaps most profoundly, this technology reconnects us with natural cycles in a way that industrial technology never has. When you use a mycelium product, you're engaging with something that's alive, that grew, that's part of the natural world. When you're done with it and it returns to the soil, you're completing a cycle that feels fundamentally right in a way that throwing plastic in a landfill never does. We've spent the past century building a civilization increasingly disconnected from nature, using materials and processes that bear no resemblance to natural systems. Mycelium offers a path to advanced technology that's aligned with, rather than opposed to, natural processes. It's high-tech and biological at the same time, and that synthesis might be essential for creating a truly sustainable civilization. So what does all this mean for you, for me, for all of us? It means the choices we make as consumers matter enormously. When companies see demand for sustainable materials, they respond by investing in and adopting those materials. When you choose a product made from mycelium instead of plastic or animal leather, you're voting with your wallet for a different kind of future. It means supporting policies and regulations that encourage bio-based materials and circular economic systems. Our current regulatory frameworks were built for the industrial age and often inadvertently favor conventional materials simply because that's what the rules were written for. It means supporting research and education in mycology and bio-based materials. The scientists and engineers who will unlock the full potential of mycelium technology are being trained right now in universities and research institutions around the world. The humble mushroom that you walk past in the forest or see in the grocery store is connected to a vast underground network that's literally holding ecosystems together. That same organism might grow the walls of your future home, become the leather in your shoes, provide the insulation in your walls, clean up toxic waste in your community, and serve as the protein in your dinner. It's not waiting for some distant future. It's happening right now in laboratories and factories and farms around the world. We are witnessing the early stages of a materials revolution that could be as significant as the discovery of steel or the invention of plastic. Except this time, the revolution is biological, sustainable, and aligned with natural systems rather than extractive and destructive. So what aspect of mycelium technology amazes you most? Can you imagine living in a home with walls grown from mushrooms? Would you wear clothing made from fungal leather? Would you eat protein grown from mycelium? We'd love to hear from you, and if there are specific aspects of this technology you'd like us to explore in more depth, let us know in the comments below. We upload videos almost daily exploring the latest technological breakthroughs that are shaping our future, so make sure to hit that subscribe button so you don't miss anything. What innovations do you think will have the biggest impact on your life in the coming years? Drop your thoughts in the comments. Thanks for watching, and we'll see you in the next video, where we continue exploring the incredible innovations that are building the future, one breakthrough at a time. See you in the next one.